Welcome to The Explainer. Today, we're diving into something that feels like it's straight out of a sci-fi movie, but it's happening right now. We're unpacking how artificial intelligence is learning to read our most critical medical scans, things like x-rays and eye exams.
So here's the big question, right? Could an AI actually be better at this than a doctor with years of training? It's a wild thought, but it's exactly what researchers are working on. And the results? Well, they're incredibly promising, but they also come with some really serious challenges we need to wrap our heads around. Okay, let's get into it. To really get why we even need AI for this, you got to put yourself in a radiologist's shoes for a minute. You have to feel the immense pressure they are under every single day. I mean, just think about it. A radiologist is looking at hundreds, sometimes thousands of these incredibly complex images a day. And in that kind of high-stakes world where one tiny mistake can change a life, the need for powerful, reliable new tools isn't just a nice-to-have, it's an absolute necessity. So how in the world do you teach a computer to see diseases inside the human body, with all the nuance of a highly trained doctor? Well, the answer lies in this kind of layered learning process. It's kind of like a hierarchy of intelligence. You start big with a broad concept of artificial intelligence. Then you narrow it down to machine learning, where systems learn from data. A really powerful type of that is deep learning, which uses these complex neural networks. And for our specific job, analyzing images, we use a super specialized tool called a convolutional neural network, or CNN for short. The easiest way to think about a CNN is that it learns to see like a person. At first, it recognizes really simple things, like edges and corners in an X-ray. Then it starts putting those together into more complex shapes and textures. And finally, after being shown thousands and thousands of examples, it learns to identify the whole pattern, like a tumor or a case of pneumonia. Okay, so the technology sounds pretty powerful in theory, but what happens when you actually pit it against highly trained human experts in the real world? How does it actually stack up? First up, let's look at a model called ChexNet. This AI was developed by researchers at Stanford, and they trained it on a massive public dataset. We're talking over 100,000 chest x-rays to spot 14 different common diseases. Now, this is where it gets really interesting. The numbers you're seeing here are called AURO scores. It's just a way to measure how good the diagnosis is. Higher is better, and a perfect score is 1.0. And as you can see, ChexNet didn't just get a little bit better. It took a major leap forward. And for pneumonia, its performance was right on par with board-certified radiologists. Just incredible. And this wasn't just a one-off. Let's look at another case from Google Health. This time, an AI was trained to detect something called diabetic retinopathy, a complication from diabetes that can actually cause blindness. This is tough stuff, because it means an expert has to spot tiny, tiny little abnormalities in photos of the back of the eye. And the results were just wow. The model scored a 0.991. That is insanely close to a perfect score. It put its performance right up there with a panel of board-certified ophthalmologists. It was just unbelievably good at telling the difference between a healthy eye and a diseased one.
And this really gets to one of AI's core strengths. An algorithm, a piece of software, will give you the exact same reading on the same image every single time. Humans, on the other hand, well, we have what's called inter-observer variability. That means two equally skilled doctors could look at the same complex scan and come to slightly different conclusions. It's just human nature. The AI completely gets rid of that inconsistency.
But it is not a perfect fairy tale. Just when AI seems like the ultimate solution, we run into some really serious kind of ghost-in-the-machine problems that we absolutely have to confront. This is a huge one. An AI is only as good as the data you train it on. So what if it only learns from images that came from one type of scanner at one hospital? Well, its accuracy can totally plummet when it sees images from a different machine. Making sure these models work everywhere, on all kinds of equipment, is a massive challenge. Then you have what's called the black box problem. Think about it. For a doctor to really trust this thing in a clinic, they need to understand its reasoning. If the AI flags something, the doctor's going to want to know why. So a ton of research right now is going into explainable AI, systems that can actually highlight the exact pixels that led to its conclusion. And that leads to the really big question: how do these tools fit into our existing medical system? If an AI gets it wrong, who's on the hook? The doctor, the hospital, the developer who made the AI? Figuring out the rules and regulations for this is a crucial next step before these tools can be rolled out everywhere. So
Here's the crucial point. We're not talking about replacing doctors. The future, at least for the foreseeable future, is all about collaboration. It's about seeing this technology as a powerful, new kind of assistant.
Yeah, this really sums it up. The emerging idea is that AI should handle the high-volume, repetitive work. It can be a first-pass filter, flagging potential problems for a doctor to review, or maybe acting as a quick second opinion. This frees up doctors to focus on what humans do best: complex problem-solving, talking to patients, and providing holistic care. And believe me, the technology is not standing still. The next frontier is something called multimodal AI. This is where the system doesn't just look at one scan in isolation. No, it pulls together everything, your entire medical history from health records, your recent lab results, all of it, to build a way more complete and accurate picture of what's going on. This kind of integrated intelligence is really the foundation for the whole vision of the smart hospital. It's a future where data-driven insights make everything better, from scheduling and managing resources to creating personalized treatment plans. It's about making healthcare smarter and more effective for everybody. So, the real takeaway here is that AI in the hospital isn't on the horizon anymore. It's already here. The question is no longer if these tools will be part of our healthcare, but how. How do we thoughtfully, ethically, and safely integrate these powerful new partners into the day-to-day practice of medicine? It's a huge challenge, no doubt, but it's one with the potential to save countless lives.